Hello, everyone. Welcome to Sleep Space. Tonight, we'll talk about Mars, the red planet, and what it might feel like to walk beneath its pale orange skies as night falls over the Martian plains. Before we begin, leave a comment sharing where you're watching from and what time it is. Whether you're here to drift off to sleep or simply to explore, we're glad you're joining us. Let's begin our journey. From Earth, Mars appears as a flickering red dot, steady in its path across the night sky. But beneath that distant light lies a frozen, rust-colored world steeped in silence. A world once alive with volcanic fire and flowing water. A world that, despite its harshness, still tempts the human imagination more than any other in our solar system. Mars is the fourth planet from the Sun, orbiting at an average distance of about 227.9 million kilometers. It takes 687 Earth days to complete a full orbit, and its rotation is strikingly familiar. One day on Mars, called a sol, is about 24 hours and 37 minutes, almost like Earth, just stretched ever so slightly. But that's where the similarities begin to fade. The Martian atmosphere is incredibly thin, less than 1% of Earth's, composed primarily of carbon dioxide. There's barely enough air to carry sound, let alone breathe. Temperatures can fall to 125 degrees Celsius at night, especially near the poles, with daytime highs barely reaching the freezing point in many regions. And yet, despite its chill and emptiness, Mars tells a story, one that is ancient, layered, whispered in rocks and dust. Imagine yourself standing near Olympus Mons, the tallest volcano in the entire solar system. It rises 21 kilometers high, almost 3 times the height of Mount Everest. But it doesn't loom like a jagged peak. Instead, its slopes stretch wide and smooth, so gentle you might not even realize you're climbing. As night falls across its summit, the temperature plummets and a pale blue dusk settles around you. The sky, thin and fragile, darkens quickly. Stars begin to appear sooner than they would on Earth. No clouds, no moisture, no sound. Only dust. Mars is dry, but not lifeless. Not entirely. Ice lingers in the soil. Frost sometimes appears on ridges just before dawn. And near the poles, great ice caps stretch out like frozen oceans, growing in winter and retreating in summer. Scientists believe water once flowed here long ago. Evidence lies in the gullies and ancient riverbeds carved into the landscape. Even today, orbital imagery suggests that salty, briny water may occasionally seep from hillsides during warmer seasons. Valles Marineris, a vast canyon system that stretches more than 4,000 kilometers, splits the Martian surface like a scar. It's over 10 times longer than the Grand Canyon, and in places deeper than Mount Everest is tall. Standing near its rim, you'd see layers of red and ochre stone folding into shadow, the wind brushing over dust that's been undisturbed for millions of years. No birds, no buzzing insects, just the quiet rhythm of the planet turning slowly under a violet sky. The silence of Mars is profound. Even rovers, like Curiosity and Perseverance, move with caution. Tiny mechanical explorers surrounded by vast emptiness. Their wheels press into powdery soil, their instruments hum quietly, and their cameras capture sunrises that look strangely familiar and alien at once. Mars has seasons, just like Earth, though they last twice as long due to its extended orbit. Spring can bring dust storms. In fact, some storms grow so large they encircle the planet entirely, obscuring its surface in swirling, rust-colored clouds for weeks. These storms, driven by solar heating and shifting winds, are among the most powerful in the solar system. At night, the surface cools rapidly. Without a thick atmosphere to trap heat, the warmth of the day disappears into the cosmos. If you stood there, you'd feel that change, not as wind, but as stillness, as a sudden, piercing cold. The planet seems to hold its breath. Shadows grow long, then fade into nothing. Look up, and you'd see Phobos and Deimos, Mars's two tiny moons, crossing the sky. Unlike our moon, Phobos orbits Mars so closely that it rises in the west and sets in the east, crossing the sky in just a few hours. Deimos, smaller and farther away, appears more slowly, drifting lazily overhead. They aren't perfectly round like Earth's moon. They look more like lumpy asteroids, captured long ago and locked into orbit. Mars is a planet of echoes and potential. Geologists see its surface as a snapshot of a younger Earth. Its rocks, untouched by weather or biology for billions of years, preserve the past in exquisite detail. Each crater, each ridge, each sedimentary layer tells a chapter in the story of a planet that once might have harbored life. No one knows for sure whether life ever existed there, but in its earliest days, perhaps over 3.5 billion years ago, Mars was warmer and wetter. It had rivers, lakes, maybe even a shallow ocean in the northern hemisphere. The ingredients for life were present: water, energy, and a stable environment. If life did arise, it would have been microbial, tiny cells adapting to harsh conditions. And if any trace remains, it's likely buried beneath the surface, shielded from radiation and time by protective rock and ice. That's one reason why future missions aim to dig, to sample, to return Martian soil to Earth. There's hope that deep within those grains lies the fingerprint of something more, an answer to the question of whether we are alone. But tonight, we aren't looking for life. We're here to experience, to explore gently, to imagine what it feels like to walk slowly across a landscape both ancient and untouched, where every pebble has sat still for eons, where the wind moves but does not speak. You take a slow breath in your imagination, watching frost glisten on distant hills. The sky turns darker, the stars sharpen, your footsteps leave no echo, only soft impressions in dust that hasn't seen movement in thousands of years. You walk toward a small rise overlooking a crater. The bowl is wide, its edges smooth, its floor littered with boulders and shadows. Above you, the constellations begin to shine. Not the same constellations you'd see from Earth, but slightly shifted, framed by a darker, thinner sky. The stillness is total. The red planet sleeps. And so we continue. Imagine waking on the surface of Mars beneath a pale dawn sky. The sun, half the size it appears from Earth, rises low and quiet on the horizon. Its light is weak, almost hesitant. It filters through the thin atmosphere, casting a soft amber glow across the rugged terrain. Dust particles hang in the air like faint whispers of motion. The world awakens not with sound, but with subtle shifts in light and shadow. Mars, though silent, is never entirely still. Subtle geological processes continue beneath the surface. The planet once boomed with volcanic activity, and though its volcanoes are long dormant, the ground still holds potential energy. Scientists have detected Marsquakes, gentle tremors that roll through its crust, providing clues about the planet's interior structure. Unlike Earth's dynamic tectonic plates, Mars has a single, rigid outer shell. But beneath that crust, heat still stirs, driving occasional quakes that ripple across ancient rock. As the light spreads, the surface reveals its varied personality. In some places, jagged rocks form broken plains, the remnants of ancient lava flows. In others, wind-carved dunes ripple like frozen waves, sculpted by the slow persistence of Martian breezes. These winds, while gentle by Earth standards, are capable of reshaping the landscape over time. They move sand across the surface, erasing old tracks and creating new patterns in silence. One of the most intriguing features of Mars is its magnetic past. Unlike Earth, Mars no longer has a global magnetic field, but scientists believe it once did. Remnant magnetism preserved in its oldest rocks suggests that the planet may have had a protective magnetosphere billions of years ago. This would have shielded its atmosphere from solar wind and cosmic radiation, creating a more hospitable environment for life. Without that shield today, Mars is vulnerable. Solar radiation bombards the surface. High-energy particles stream from the sun and interact directly with the upper atmosphere, gradually stripping it away. This process, called atmospheric escape, is thought to be one of the main reasons why Mars transitioned from a warm, wet world to the cold desert we see now. Despite this, the atmosphere that remains plays a role in shaping the Martian climate. Though thin, it creates just enough pressure for carbon dioxide to freeze at the poles, forming seasonal dry ice caps. During winter, carbon dioxide from the atmosphere condenses directly onto the surface, adding layers of white frost to the landscape. In spring, this frost sublimates, turning directly from solid to gas, feeding winds and triggering seasonal flows. This cycle of frost and thaw is one of Mars's most subtle yet mesmerizing processes. From orbit, satellites have captured time-lapse images of shifting patterns near the poles, dark fans, streaks, and spider-like structures etched into the ground as gas rushes upward through layers of ice and dust. It's alien, yet beautiful. A planet in motion, even in its deep stillness. High in the southern hemisphere lies the Hellas Basin, one of the largest impact craters in the solar system. Spanning over 2,000 kilometers wide and nearly 7 kilometers deep, this vast depression is thought to have formed from a colossal asteroid impact billions of years ago. Within its walls, the atmosphere is slightly denser than surrounding regions, and temperatures can be marginally warmer. If humans ever settle Mars, places like Hellas may offer natural protection from radiation and cold. The idea of human presence on Mars isn't science fiction anymore. Robotic explorers have laid the groundwork. Data from orbiters, landers, and rovers paint a picture of a planet both challenging and inviting. Future missions may involve astronauts stepping onto red soil, their shadows cast across ancient dust. Habitats may one day nestle in craters or be carved into hillsides, protected from the harshness above. But what would it feel like to live there? Mars has only 38% of Earth's gravity. That means a person who weighs 70 kilograms on Earth would weigh just 26 kilograms on Mars. Movements would feel lighter, almost graceful. Leaping would require less effort, and falling would be slower. Yet the body, adapted to Earth's gravity, might struggle over time. Muscles would weaken, bones might lose density. Exercise and adaptation would be crucial to survival. Outside the shelter of habitats, the air would remain unbreathable. Pressure suits would be mandatory. Communication with Earth would involve a delay. Any message would take between 5 and 20 minutes to reach home, depending on orbital positions. That time gap creates a feeling of distance that's difficult to grasp. Mars is not just far away physically, it's far in terms of experience. Still, it's a place where the human spirit would thrive. Every sunrise would be a reminder of our capacity to reach beyond boundaries. Every sample collected, every new crater mapped, would add to the collective story of exploration. Mars is a canvas of possibility, its surface painted in ancient history and future dreams. Consider Jezero Crater, the landing site of the Perseverance rover. Once home to a river delta, it offers layered evidence of past water flow, sediment deposits that tell a story of time, erosion, and perhaps even habitability. Scientists chose this site for its rich geological diversity, hoping it might preserve biosignatures from a time when life could have existed. Perseverance, along with its companion helicopter, Ingenuity, is part of a new generation of robotic explorers. These machines don't just study the surface, they interact with it. They drill, sample, analyze, and in some cases, prepare caches of material to one day be returned to Earth. That return mission, still years away, represents a profound leap, bringing a piece of another world back home. As the Martian sun climbs higher, shadows shrink. The temperature rises, though only slightly. In some equatorial regions during midsummer, the ground might warm to a few degrees above zero. But without humidity, the air remains crisp and dry. Nothing melts. Snow and frost sublimate, disappearing into vapor without a drop of liquid. This lack of liquid water defines much of Mars's current state. While Earth is blue and flowing, Mars is parched. Any water that exists does so as ice, locked in polar caps beneath the surface, or potentially in hidden aquifers. The search for subsurface water is ongoing. Radar instruments aboard orbiters have detected reflections that may indicate liquid brines beneath the southern ice cap, though the evidence remains debated. These underground reserves, if confirmed, would be vital not just for science, but for future survival. Water is the key to life. It can be used for drinking, growing food, and even generating oxygen and rocket fuel through electrolysis. Colonizing Mars hinges on understanding and utilizing this resource wisely. You walk now through a landscape shaped by extremes. Hills rise like ancient bones from the dust. Craters line the horizon. The sky, faintly orange during the day, fades to purple as evening returns. A low haze drifts across a nearby valley, kicked up by afternoon winds that now slow and still. Dusk on Mars brings with it a quiet transition. The temperature drops rapidly, the ground cools, the air thins. The sun slips below the horizon like a fading ember. Shadows return, long and delicate, stretching across the quiet plain. You stop for a moment and look up. The stars are beginning to return. Phobos has risen again, moving faster than before. It arcs across the sky with mechanical precision, its orbit pulling it closer to Mars with every pass. One day, millions of years from now, it will crash into the surface or be torn apart by tidal forces, forming a ring. Even here, change is inevitable. For now, though, everything holds. The dust settles, the sky darkens. Mars breathes in silence. As the stars sharpen in the deepening Martian sky, the planet begins to glow with a quiet luminescence. Reflected sunlight touches the ice at the poles and glints off dust-slick rocks. The landscape does not sleep in the way Earth does. Instead, it enters a long, slow exhale, quiet, cold, and constant. You find yourself near the edge of a dried-out riverbed. The terrain is cracked and scattered with smooth stones, like forgotten memories of flowing water. Scientists call these ancient channels outflow valleys. They're some of the strongest evidence that Mars once had significant surface water. These valleys are not narrow trickles. They're wide, deep features that suggest powerful floods surged across the Martian surface billions of years ago. How could that be? For water to exist in liquid form, Mars would have needed a thicker atmosphere and higher temperatures. Geological evidence points to such a time, perhaps during the Noachian period, over 4 billion years ago. Back then, the planet may have had a hydrological cycle not unlike Earth's. Rainfall, rivers, lakes, maybe even oceans. Over time, this cycle disappeared, leaving behind the frozen silence that now defines the world. Walking along the bed of that long-gone river, the stones beneath your feet are polished, rounded. They've been here for eons, untouched by foot or paw. No wind is strong enough to move them now. They are artifacts of a forgotten age, a time when Mars may have been blue instead of red. The colour of Mars comes from its surface minerals. The planet is rich in iron, and when that iron oxidizes, essentially rusts, it gives the soil its reddish hue. This iron-rich dust is extremely fine, clinging to everything. It coats rover wheels, settles on solar panels, and gives the sky its salmon-pink tone during the day. But at night, when the atmosphere cools and the dust hangs low, the sky takes on deeper, more muted tones. Plum, indigo, black. Above, constellations shift. Familiar patterns look slightly altered due to Mars's different position in the solar system. The stars feel closer. The thin atmosphere offers little distortion, giving the sky an almost crystal clarity. There's no light pollution, no clouds, just the openness of space and the silence of a world listening. You continue toward a cluster of small hills, perhaps remnants of lava domes from a time of volcanic activity. Mars's surface is littered with such features. Unlike Earth's plate tectonics, which recycle the crust, Mars has a preserved surface. It's a planetary time capsule. The oldest regions, like the southern highlands, are densely cratered, while younger plains, like those near the northern lowlands, show fewer impacts. The contrast between the north and south is one of Mars's great geological puzzles. The northern hemisphere is lower, smoother, possibly once covered by a vast ocean. The southern hemisphere is higher, rougher, and older. This hemispheric dichotomy is a defining characteristic of the planet, and no single explanation yet fully accounts for it. Some theories suggest a massive impact early in Mars's history reshaped its crust. Others propose volcanic or tectonic causes. As you climb the low ridge, you notice streaks in the soil. Dark, narrow lines running down slopes. These are known as recurring slope lineae, or RSLs. They appear seasonally, darkening and then fading over time. Their origin is debated. Some scientists think they may result from flows of briny water, salt-laced enough to remain liquid even in extreme cold. Others suspect they are dry landslides triggered by temperature shifts. Whatever their cause, they are dynamic, a rare sign of motion on an otherwise frozen world. At the top of the ridge, the land opens wide. You can see for kilometers in every direction. The surface stretches out, barren and beautiful, etched with history. Craters dot the landscape, each a record of impact. Large craters often have central peaks, uplifted from the shock of collision, while smaller ones are bowl-shaped, surrounded by ejecta. The density and distribution of these craters help scientists estimate the age of different regions. One such crater lies below you now. Its rim is broken in places, worn by wind and time. A small dune field has formed inside it, shaped by slow-moving air currents. Despite the thin atmosphere, Martian winds can still shift sand, particularly in regions with low gravity and fine dust. These dunes migrate over decades, creeping like shadows across the crater floor. As night deepens, you begin to sense the rhythm of the planet more intimately, not through sound or motion, but through presence. Mars does not pulse like Earth, filled with waves and noise and life. Instead, it hums softly beneath the surface, its stillness a kind of language. Each rock tells a story, each shadow marks time. The planet moves slowly, yet never stops. If you were to stay here for a full Martian night, you'd feel the extreme cold seep into every material. The surface drops below, while 100 degrees Celsius, sometimes much lower depending on location and season. Without the insulating effect of a thick atmosphere, the warmth of the day is lost quickly. Even electronics on rovers must carry internal heaters to survive the chill. Yet despite the cold, the planet doesn't freeze in every way. Below the surface, temperatures rise slightly, and models suggest that with enough depth and insulation, pockets of liquid water might exist. These subglacial environments, if real, could be refuges for life. On Earth, life thrives in similar places, deep beneath the Antarctic ice or in subterranean lakes. Mars remains one of our best hopes for finding life beyond Earth, not because it's hospitable now, but because it might once have been. And if life began there, even in microbial form, it could reveal something profound about our own origins. It would suggest that life is not a cosmic fluke, but a natural outcome of planetary chemistry. You descend the hill slowly, the sky now fully dark. Phobos has long since set. Deimos hangs low and faint, barely more than a point of light. The stars gleam in all directions, unblinking. You feel small but not alone. Mars does not feel empty, it feels paused, as though waiting. The ground crunches faintly underfoot, more imagined than heard. Each step leaves a mark that could last for centuries. Without rain, without plants or animals to disturb the soil, impressions remain. Even the tracks left by the earliest rovers are still visible, their paths frozen in dust. Ahead lies a narrow cave entrance, a collapsed lava tube perhaps. These tubes form when the outer layer of a lava flow cools and solidifies, while the molten interior continues to move. Once emptied, the resulting tunnel can remain stable for millions of years. On Mars, they may offer shelter, both for potential life and for future explorers. You pause near the entrance, staring into the black. The air is still, the stars are distant, the planet is vast. And in that moment, you realize Mars isn't a dead world, it's a resting one, waiting to be understood, waiting to be remembered. As you step closer to the cave's entrance, a deep hush surrounds you. Lava tubes like this one stretch for kilometers underground, formed by ancient volcanic flows that cooled from the outside in. On Earth, they can shelter complex ecosystems. On Mars, they offer protection from radiation, from dust storms, from the frigid air. If humans ever settle here, places like this may become home. The temperature inside remains more stable than the surface. Instruments have detected subsurface regions on Mars that maintain relatively moderate temperatures year-round. This natural insulation offers a potential refuge not only for explorers, but possibly for microbial life. Shielded from ultraviolet radiation and preserved in the dry cold, such life, if it exists, would be tenacious, slow-growing, and ancient. As you descend into the tube, your eyes adjust to the low light. The rock walls are smooth in some areas, jagged in others. Frost clings to the edges where the chill deepens. The silence intensifies. There's no echo, just the sense of being wrapped in stone that hasn't been disturbed for millennia. Emerging once again onto the open plain, you notice the faint shimmer of frost forming on the ground. Even a small amount of atmospheric moisture, just a trace, can condense when temperatures drop low enough. These delicate ice crystals glisten like pale dust under starlight, vanishing again with the warmth of the rising sun. Your journey continues northward across the vast flat region known as Utopia Planitia. This is the largest confirmed impact basin in the solar system, stretching more than 3,000 kilometers wide. Billions of years ago, an asteroid collided with Mars, carving out this enormous depression and forever altering the planet's surface. What's remarkable is that Utopia Planitia may hold vast reserves of water ice just beneath its surface. Radar data from orbiting satellites suggest that frozen layers extend for hundreds of meters in some areas. If Mars was once warmer and wetter, this ice could be the residue of ancient seas, now trapped in a frozen slumber. The Viking 2 lander touched down here in 1976, becoming one of the first machines to explore Mars directly. Its instruments measured soil chemistry, wind patterns, and temperature variations. Though it detected no signs of life, it laid the groundwork for decades of exploration that followed. Even now, its silent frame remains on the Martian soil, a relic of human curiosity. You pause at the edge of a shallow crater, its rim softened by erosion. The floor is coated in dust, layered over eons. In the center lies a rock shaped by ancient wind, a ventifact, smoothed and grooved by relentless abrasion. On Earth, these are found in deserts, where sand-laden winds sculpt stone over time. Here, the process is slower, but no less deliberate. Wind is one of the few active forces on Mars today. Despite the planet's thin air, it shapes dunes, forms dust devils, and drives global storms. In the right conditions, these swirling columns of air can reach several kilometers in height. Rovers have captured images of dust devils twisting silently across the plains, lifting fine particles high into the sky. You turn your gaze upward. The sky is nearly black, dotted with sharp stars. There's no haze, no glow of distant cities, just the deep, uninterrupted stretch of space. Earth is out there, a pale blue point invisible to the eye but present in the mind. The space between is vast, but not impassable. Machines have crossed it. One day, so will people. As you continue walking, you imagine the path of the Perseverance rover, far away in Jezero crater. It's studying rocks that may contain trapped organic molecules, compounds built from carbon, hydrogen, and oxygen. These are not signs of life by themselves, but they hint at the conditions necessary for biology to emerge. Perseverance's mission is not only to study the present, but to prepare for the future. Its samples, sealed in titanium tubes, may one day return to Earth for detailed analysis. The idea of returning Martian soil to Earth carries profound scientific weight. Inside each gram of regolith could lie answers to fundamental questions. Did Mars ever support life? What was its climate like before the atmosphere thinned? How did its geology evolve? Each answer brings us closer to understanding our own planet, and perhaps others like it. Further south, the surface is marked by chaotic terrain, fractured blocks of crust broken and jumbled together. These regions, like the area known as Aram Chaos, may have formed when underground water erupted violently onto the surface, collapsing the overlying land. The result is a labyrinth of canyons and broken stone, as if the planet fractured and froze in the act of movement. Nearby lies the massive canyon system Valles Marineris, You begin making your way toward it, though it will take days to reach. Spanning over 4,000 kilometers, it cuts across the planet like a scar. Its walls rise several kilometers above the canyon floor. The scale is almost incomprehensible, so vast that it would stretch from New York to Los Angeles if placed on Earth. Scientists believe the canyon formed not from flowing water, but from tectonic and volcanic processes. As the nearby Tharsis volcanic region swelled from underground magma, the crust stretched and cracked, creating faults and fractures that widened into valleys over time. Landslides and erosion deepened the canyon further. Approaching the edge of this immense feature, you peer into shadow. The temperature here can be even more extreme, with cold air sinking into the canyon depths at night. Some areas contain layered deposits, possibly sediments laid down by ancient water or wind. These layers record time like pages in a book, one that scientists are still learning to read. Mars doesn't have weather in the way Earth does, but it has seasons, and they affect everything. During southern summer, the planet is closer to the sun, and dust storms become more frequent. These storms can grow quickly, sometimes expanding to cover entire hemispheres. They obscure the surface, lift fine dust into the atmosphere, and change the temperature patterns across the planet. Even during these storms, the wind speeds rarely exceed 100 kilometers per hour. Because of the low air density, the force of the wind is much weaker than it would be on Earth. Still, the movement of dust and the alteration of light have powerful effects. Solar-powered rovers must pause during such events. Instruments recalibrate. Images take on a hazy, golden tone. Dust is more than a nuisance. It's a geological force. Over time, it wears down rock, fills in craters, and smooths sharp edges. It also carries chemical clues, including perchlorates, chlorine-containing compounds found in Martian soil. These compounds are toxic to humans, but they also point to complex chemistry, shaped by exposure to radiation and time. The presence of perchlorates raises questions about how life might survive on Mars. On Earth, some bacteria can metabolize these compounds. If life ever arose on Mars, it may have developed similar adaptations, strategies for enduring in an oxidizing, salty, cold environment. You move along the edge of Valles Marineris, tracing its curvature. The canyon narrows in places, then opens again into wide basins. Landslides have carved out fan-shaped deposits. Small gullies hint at ancient movement. The rock walls, stained in layers of red and brown, glow softly in the starlight. From this vantage point, the scale of Mars becomes clear. It is not a small, barren world. It is vast, sculpted, and patient. It has waited through billions of years of silence. It has endured impacts, eruptions, floods, and freezes. And now it waits again, not for rescue, but for recognition. You sit near the edge and look out. The silence is complete. The stars continue overhead, and Mars turns slowly beneath them, its midnight deepening with each passing moment. The view from the rim of Valles Marineris remains with you as you begin to move again. The canyon, deep and wide, stretches endlessly into the darkness. Its sheer walls speak of tectonic shifts and erosion on a scale difficult to comprehend. Time, on Mars, doesn't just pass, it accumulates. Every fracture, every dust-filled gully is a marker of eons, laid bare and untouched. Your journey takes you west now, toward the Tharsis region, a massive volcanic plateau that dominates the Martian Western Hemisphere. It's home to Olympus Mons, the tallest known volcano in the solar system, and 3 other enormous shield volcanoes, Ascraeus Mons, Pavonis Mons, and Arsia Mons. Together, they form a near-linear chain that crosses the planet like the vertebrae of an ancient, sleeping creature. As you approach this region, the terrain begins to rise. The air, already thin, becomes thinner. Even on a planet with no breathable atmosphere, elevation still matters. Olympus Mons, towering 21 kilometers high, stretches so wide that its base would cover the entire state of New Mexico. Its caldera, the collapsed summit crater, spans 80 kilometers across, large enough to fit multiple cities within its rim. Unlike Earth's volcanoes, shaped by shifting plates and rapid eruptions, the Martian surface allowed Olympus Mons to grow slowly and steadily over hundreds of millions of years. There were no tectonic plates to carry the volcano away from its heat source, so it built up layer by layer, lava flow by lava flow, until it reached impossible heights. Climbing Olympus Mons would be unlike any terrestrial ascent. The slope is gentle, averaging only a few degrees. You wouldn't even realize you were climbing at first. The vast expanse would feel flat underfoot, until you remembered you were walking up the side of a volcano so large it curves with the planet itself. The surface is covered in lava plains, solidified flows that form during the volcano's many active periods. Some are rough, pitted with collapse pits and volcanic vents. Others are smooth, resembling cooled glass, rippled by ancient motion. Standing here, it's almost impossible to grasp the silence that followed such fiery events. Where there was once eruption and heat, now there is frost and shadow. Volcanism is one of Mars's most important geological processes. Though currently dormant, the planet's volcanic past shaped its crust, released gases into the atmosphere, and may have helped sustain a warmer climate billions of years ago. The heat from volcanic activity could have melted underground ice, creating temporary lakes or even hydrothermal systems, environments that on Earth are known to support life. Descending from the flanks of Olympus Mons, you make your way toward the plains below. To the east lies a network of collapsed features called Noctis Labyrinthus, the labyrinth of night. This system of deep, branching canyons connects the Tharsis Rise with the eastern end of Valles Marineris. The terrain here is fractured and chaotic, shaped by the stretching and breaking of the crust during the uplift of Tharsis. Exploring Noctis Labyrinthus is like stepping into a dreamscape. The canyons are narrow and winding, their walls steep and shadowed. Some parts may have once contained lakes, others appear shaped by slow erosion, perhaps even by underground water movement. This region captures the interplay between tectonics and erosion, between fire, and ice, that defines much of Mars's surface. As you wander these canyons, you begin to notice the subtle color changes in the rock. Spectral data from orbiters have revealed signs of clay minerals here, formed in the presence of water. These clays are significant because they tend to form under neutral pH conditions, a sign that past water may have been neither too acidic nor too alkaline. In other words, it may have been suitable for life. Mars holds many such clues in its rocks. Over time, its surface has preserved a chemical record of change. Sulfates, perchlorates, and iron oxides all speak to different environmental conditions. Each layer, each exposed outcrop, tells a fragment of a longer story. A planetary biography still being pieced together. Emerging from the labyrinth, you step onto the Syria Planum, a plateau of ancient volcanic rock. Here, the ground is cracked and ridged, sculpted by tectonic forces that once pushed the crust outward. These long fissures, called grabens, stretch for hundreds of kilometers. They're remnants of the stresses that accompanied the rise of Tharsis, a geologically active period that may have lasted 1 billion years or more. In some places, wind-blown dust has collected in grooves. In others, boulders lie where landslides once tumbled. The evidence of movement is everywhere, even if that movement stopped long ago. To the north, your path brings you closer to the equator, where daytime temperatures can briefly rise above freezing. Here, frost may be rare, but radiation is stronger. Without a magnetic field or thick atmosphere, cosmic rays and solar particles bombard the surface daily. Any life, past or present, would need to find shelter beneath rock or ice. That's why attention has turned towards subsurface exploration. Instruments aboard rovers and orbiters have hinted at buried ice, salt deposits, and possibly even transient water. One goal of future missions is to drill deep, several meters or more, to study these hidden layers. They may hold not just water, but the preserved organic chemistry of Mars's ancient past. You rest now at the edge of a shallow basin, watching as Mars's two moons once again begin their journey across the sky. Phobos appears first, small but fast. It races overhead in just over 7 hours, casting a faint, sharp-edged shadow as it passes. If you blinked, you might miss it. Deimos follows later, slower and dimmer. Its orbit is wider, its presence more subtle. Neither moon is round. They resemble captured asteroids, irregular, pock-marked and small. Phobos is so close to Mars that its orbit is decaying. In millions of years, it will either crash into the surface or break apart into a ring. For now, it simply loops overhead again and again, a silent sentinel watching the empty plains. You gaze up as the stars deepen. The sky here is unfamiliar, yet beautiful. Without an atmosphere thick with weather, the stars do not twinkle. They shine steadily. Planets are visible: Jupiter, Saturn, even distant Uranus sometimes. Pale dots in a sea of dark velvet. Earth at this distance would be nothing more than a bluish speck lost among the constellations. There is something humbling about that thought, that so much history, so much life, exists on a distant speck you can no longer see. And yet here you are, standing on another world, a world not alive in the way Earth is, but rich with its own history, texture, and presence. As the Martian night continues, the temperature drops again. The ground crunches with frost. The wind, such as it is, flows low across the surface, carrying dust from basin to basin. Everything slows, everything stills. You look out across the plains and see nothing moving, but you know that beneath the surface, within the rocks, inside the frozen soil, there is potential. There are stories waiting to be read. There is memory. And perhaps in some deeply buried chamber, there is something even more. Not alive, maybe, but once alive, or soon to be. The landscape stretches before you like a memory frozen in time. After departing the towering Tharsis volcanoes and the fractured plains of Syria Planum, you find yourself on the vast region known as Amazonis Planitia. It is a wide, relatively flat plain that bears the signature of one of Mars's most enigmatic periods, the Amazonian epoch. Amazonis is named not for its resemblance to Earth's Amazon, but for the name assigned to a time period on Mars's geological timescale. The Amazonian period is the most recent, and it spans the last 3 billion years, a time defined more by stillness than activity. Compared to earlier epochs, fewer impact craters formed, and signs of flowing water became rare. Yet even in this stillness, change continued, albeit quietly. The plain is shaped by ancient lava flows that once emerged from nearby volcanic vents. The rock here is smooth, undisturbed. In many places, it almost looks paved, as though nature carefully laid down basalt sheets and left them untouched. Scattered across the plain are peculiar ridges and mounds, some of which scientists believe were formed by slow, icy processes, perhaps permafrost beneath the surface, expanding and contracting over thousands of Martian years. Amazonas also offers some of the best preserved evidence of wind-driven activity. Dust devils have left their spiraling paths etched into the soil. Some tracks are recent, sweeping through the dark surface and revealing lighter material beneath. The Martian winds, while faint, are patient. Over time, they carve, shape, and sculpt, and Amazonas is their canvas. The sky glows faintly with the soft light of the rising sun. On Mars, sunrises begin not in orange or pink, but in a cool blue, caused by the scattering of fine dust in the thin atmosphere. It's a reversal of Earth's warm dawns. A colder kind of light, but just as beautiful. You move north, approaching the region of Elysium Planitia, home to some of Mars's youngest lava plains. Here, the InSight lander touched down in 2018, delivering a suite of seismometers and heat probes to study the Martian interior. Thanks to InSight, we learned that Mars still trembles. Not violently, but enough to reveal that the red planet is not entirely geologically dead. Marsquakes, as they are called, provide a glimpse into the crust and mantle. Some are caused by internal stresses. Others might result from surface cooling or even meteorite impacts. On Earth, tectonic plates shift and collide, causing quakes. On Mars, the crust is still settling, still adjusting to a long, quiet cooling. InSight also detected signals from deep beneath the surface, subtle echoes that hinted at a partially molten core. The planet, despite its frigid surface and extinct volcanoes, still carries internal heat. That heat might drive occasional activity, slow convection in the mantle, faint quakes, or chemical changes in subsurface ice. You pause near a shallow depression, one of many craters that dot the plain. This one is small, maybe a few 100 meters wide, but what draws your eye is not its shape, but its color. The crater reveals layers, dark basalt beneath a lighter dusting of soil. These layers are nature's timeline, each one formed under different conditions, and each tells a different chapter of Mars's quiet story. Continuing your journey, you approach a region marked by strange circular features. Not impact craters, but remnants of past climate change. Known as brain terrain or lobate debris aprons, these formations appear to flow around mountains and cliffs, resembling the pattern of soft tissue or melted wax. They are thought to be ice-rich, covered by a protective layer of rock and dust. Radar from orbit confirms this. Hidden glaciers lie beneath the Martian surface, preserved under an insulating crust for millions of years. These glaciers may be the largest reservoirs of near-surface ice outside the polar caps. They hold frozen secrets, perhaps even air bubbles or dust from ancient Martian atmospheres, waiting to be studied. You climb gently toward a region known as Arcadia Planitia. It's cold here. The sunlight feels thinner, more diffuse. The air remains still. Arcadia is another place where water ice lies just beneath the ground. Some impact craters in this region appear recent, young enough that ice exposed by the impact hasn't yet sublimated into the thin air. In Mars's delicate climate balance, such moments are fleeting. Water on Mars is elusive. It exists as vapor in the atmosphere, locked as ice in the soil, or hidden in polar caps. In the distant past, it may have flowed in rivers and collected in lakes, but today it clings to shadows and hides beneath dust. and yet it remains a key to understanding the planet's history and its future potential for life. Resting now, you look to the sky once more. The stars above you shine with the clarity only possible from a world without clouds. The Milky Way stretches from horizon to horizon, not blurred or dimmed, but sharp and radiant. Even without a magnetic field to paint auroras, Mars still offers a sky full of wonder. As you sit in silence, you reflect on the strange stillness that defines this world. Mars is not lifeless, it is simply paused. The energy it once had is not gone, just buried. Its rivers may have dried up, but their paths remain etched in stone. Its volcanoes may have quieted, but their stories remain in their slopes. You rise again, and your path curves eastward toward Utopia Planitia. This is one of the largest recognized impact basins in the solar system, more than 3,000 kilometers wide. Long ago, something vast struck Mars, creating a bowl so large that its rim disappears over the horizon. In the basin's center, flat plains stretch for hundreds of kilometers. Here, the Viking two-lander once set down, in 1976. It was one of humanity's first attempts to touch the Martian surface and search for life. Viking sent back photos of reddish soil, scattered rocks, and a hazy sky. It also conducted biology experiments, tests designed to detect microbial life in the soil. The results were inconclusive. Some signals suggested chemical reactions that might have been biological, but others pointed to reactive soil chemistry, perch laurates that confused the instruments. It remains one of Mars's enduring mysteries, whether life was missed by inches or simply not present at all. Today, Utopia Planitia is under new scrutiny. Beneath its surface, radar has detected a vast body of water ice, possibly the size of Lake Superior. This ice lies not at the poles, but near the mid-latitudes, where conditions might allow for easier access. For future explorers or even settlers, this could be vital. As the evening deepens, a soft glow begins to rise in the northern sky. It's not light pollution, there are no cities here, but the gentle scattering of sunlight on airborne dust. This phenomenon, known as the false dawn, is unique to Mars. The planet's ever-present dust, suspended high in the atmosphere, catches the sunlight just before it crests the horizon. The light dances across distant mesas and flat plains. Shadows stretch long, rocks glisten faintly with frost. The wind stirs once more, just enough to carry dust along the ground. It whispers across boulders, follows cracks, and carves small ripples in the soil. You close your eyes for a moment, listening. The silence is not empty. It is full of memory. As you leave behind the icy lowlands of Utopia Planitia, the terrain gradually transitions. You're entering a region shaped by both ancient water flows and newer, puzzling activity. To the southeast lies one of the most intriguing landscapes on Mars, Cerberus Fossae. From orbit, Cerberus appears as a network of long, parallel cracks that slice across the Martian crust. These fissures stretch for hundreds of kilometers, as if the ground split open under invisible pressure. The terrain around them is dark, smooth, and uncommonly fresh, geologically speaking. Some flows here may be less than 10 million years old, a blink in planetary time. What caused these massive fractures? Many scientists believe they formed due to tectonic stretching, where underground movement caused the crust to tear open. Others suggest they may mark subsurface dikes, channels through which molten rock forced its way upward, cracking the surface in the process. Either way, the result is dramatic. Giant scars that reveal a Mars that still shifts and breathes. Cerberus Fossae is also home to one of Mars's greatest recent mysteries, the source of seismic signals detected by the InSight lander. Some of these Marsquakes seem to originate near this very region. This suggests that Cerberus is still active in some way, even if quietly. It might be settling, cooling, or releasing small amounts of energy trapped within the crust. As you drift over the fissures, you notice something else. Ancient lava plains flowing around them, as if the fractures came later. The surface is smooth and dark, shaped not by water but by fire. These plains, known as Athabasca Valles, resemble Earth's basaltic flood landscapes, places where lava once surged across the ground in vast sheets. And within these flows are peculiar rippled patterns. Some of them look like frozen waves, while others resemble coils and ropes. Classic signs of lava cooling and hardening in motion. Beneath the frozen appearance, these rocks once flowed like liquid. It's easy to forget that even cold, barren Mars had its fiery days. You continue eastward, following the trace of the equator, and come upon another wonder, a massive circular formation known as Orcus Patera. It lies between the volcanoes of Elysium and the mighty Tharsis Bulge, yet its shape is unusual. Unlike typical impact craters, Orcus Patera is elongated, stretched as though something scraped the surface at a shallow angle. Was it formed by a grazing meteorite? A collapsed volcanic structure? The origin remains uncertain, but what's left is haunting. A long, low basin rimmed with raised edges and dusted in red. Within its walls, wind has sculpted the soil into waves and dunes. The basin lies silent now, a forgotten wound in the crust. South of here, you reach the dark expanse of Medusae Fossae, one of the strangest and most poorly understood formations on the planet. From above, it resembles a massive pile of layered deposits, soft, wind-eroded, and strangely uniform. Some parts appear almost like ash, piled high and then carved by centuries of wind. No one knows exactly how Medusae Fossae formed. One leading theory suggests it's made of volcanic ash or pyroclastic material, ejected long ago from explosive eruptions. If true, it would represent one of the largest volcanic deposits in the solar system, a ghostly relic of a violent Martian past. The layers here are soft, and the wind cuts through them easily. Towers of rock rise and collapse. Ridges form and vanish. The entire region is slowly vanishing, grain by grain, into the Martian sky. You can almost hear the erosion, the slow, patient sculpting of dust against stone. From here, you begin to angle southward. The temperature drops. The air grows even thinner. You're approaching the southern highlands, one of the oldest parts of Mars. These highlands are dense with craters, scars from an ancient bombardment period that ended over 3.5 billion years ago. Unlike the younger northern plains, the south retains its ruggedness. The ground is pitted, uplifted, and stained with dark ejecta from impact long past. Some craters span tens of kilometers. Others are shallow, filled with sediment and ice. One of the most famous is Hellas Planitia, a basin over 2,000 kilometers wide and 7 kilometers deep. It's the largest visible impact structure on Mars and one of the deepest in the entire solar system. Its depth creates a unique microclimate. Air pressure here is higher than anywhere else on Mars, and frost lingers longer at its base. Hellas is like a natural bowl, trapping dust and air. Some of the planet's most intense dust storms originate here, swirling upward from the basin and fanning across the southern hemisphere. Nearby, nestled in the highlands, are valleys that whisper of ancient water. One such network, known as Valles, resembles a branching tree, dry now, but unmistakably shaped by flowing liquid. Long ago, water carved these channels. Whether it came from rainfall, melting ice, or underground springs is still debated, but the marks it left behind are undeniable. This region feels older. Even the light seems subdued, filtered through a sky heavy with fine dust. Shadows lengthen, crater rims catch the last of the sunlight, glowing faintly with a golden hue before surrendering to dusk. You descend toward a feature known as Argaea Planitia, a vast impact basin that, like Hellas, holds secrets from Mars's most violent chapter. Surrounding it are ridged terrains and eroded channels. Some scientists believe that during a brief warm period, Argaea may have once filled with liquid water, a temporary lake that endured for thousands of years before vanishing. Around its edges, the soil is mottled with minerals known as clays, substances that only form in the presence of water. These clays are fragile records, holding onto a chemistry that hints at the possibility of ancient life. As you pause on the basin floor, you notice the air feels ever so slightly heavier. The wind, though faint, carries more dust. The temperature, while still frigid, is buffered by the lower elevation. Mars is not a planet of uniformity. It has microclimates, patterns, and whispers of forgotten environments. From this vantage point, the southern sky opens up. The stars wheel slowly overhead. A few faint meteors trace paths across the black. Every so often, a tiny glint marks a passing satellite, human technology circling a world still largely untouched. The moon. Phobos appears again, racing across the sky in its frantic orbit. Its path is irregular, almost alarming in its speed. It takes just 7.6 hours to circle Mars, faster than the planet rotates. Deimos, in contrast, is distant and slow. It barely moves across the night, like a dim companion lingering at the edge of vision. Both moons are thought to be captured asteroids, their lumpy shapes and cratered surfaces evidence of their chaotic origins. Someday, Phobos may break apart, pulled by tidal forces into a ring around Mars. But for now, it soars, casting fleeting shadows across the plains. You lie back and watch it pass overhead, a silent sentinel against the Martian sky. Everything here is quiet, but nothing is still. The planet continues its subtle movements, eroding, cooling, shifting. And through it all, it waits, not for rescue or rebirth, but for discovery, for understanding. Mars, though quiet, is never truly silent. As dawn rises over the southern highlands, the light returns slowly, filtered through layers of airborne dust. The reddish haze tints the sky, painting the landscape in soft hues of amber and rose. Shadows retreat into crater walls and along the grooves of ancient riverbeds. You begin your quiet ascent toward one of the most compelling regions in Martian geology, the Noachian terrain. This is the oldest crust on Mars. These rocks and ridges have remained largely untouched for more than 4 billion years. Cratered, fractured, and eroded, they preserve the scars of the early solar system, when Mars was young, wet, and still undergoing violent change. Among the most fascinating areas in this terrain is a network of valleys called the narrated valles. These sinuous channels stretch across the highlands like ancient veins, once carved by persistent water flow. Their curves are gentle, their sides steep. From above, they resemble dry riverbeds on Earth. The resemblance is striking, a visual echo of our own planet's hydrological past. The fact that these valleys exist at all is a testament to a time when Mars had a thicker atmosphere, one that could support rain or snowmelt. Some segments even show signs of repeated flooding, suggesting they weren't formed by a single catastrophic event, but by slow and sustained erosion. You move farther south and find yourself above Holden Crater, a wide, complex structure whose walls are laced with layered deposits and clays. Holden is particularly special. It's believed to have once held a lake, fed by a channel called Uzboy Valles that carved its way through high terrain. Within the crater's basin, sediment layers stack like pages in a book, each one recording a different chapter of Martian history. Some of these layers show fine laminations, the kind formed when silt settles in standing water. Others contain clays and sulfates, chemical traces of long-term water-rock interaction. These are the quiet signatures of habitability, not proof of life, but proof of the conditions that could support it. If life ever existed on Mars, places like Holden would be the first to whisper its secrets. You continue onward toward the boundary between the highlands and the vast northern lowlands, a sharp transition known as the Martian dichotomy. The elevation drops steeply here, and with it, the terrain becomes smoother, younger, and less cratered. The contrast is so stark that scientists have long wondered if it marks a massive impact basin, perhaps the largest in the solar system, or if it's the product of ancient tectonic activity. This boundary is not just a change in altitude, it's a geological frontier. Along it lies a region known as Arabia Terra. From orbit, it appears mottled and layered, its mesas and buttes carved by billions of years of wind and weather. Unlike the volcanic plains or the icy poles, Arabia Terra is defined by erosion. Its terrain seems almost hollowed out, like a sculpture slowly worn away by time. What's peculiar about Arabia Terra is that it may once have hosted explosive volcanism, the kind not typically associated with Mars. Vast deposits in the area suggest eruptions so powerful they rivaled Earth's most extreme events, like those at Yellowstone or Toba. If true, this region may have shaped the climate of early Mars in dramatic ways, spewing ash and gas into the atmosphere and influencing rainfall, temperature, and erosion patterns across the planet. And then there's Eden Patera, a depression that resembles a volcanic caldera more than an impact crater. With no central peak, no raised rim, and irregular edges, it doesn't fit the mold of a typical impact feature. It may represent a collapsed supervolcano, long since silenced, its violent past hidden beneath layers of dust. As you drift over the lowlands once more, you encounter the northern plains. Broad, flat expanses that speak of quietude rather than violence. One such area is Acidalia planitia, known to many from its appearance in science fiction, but grounded in real science. This region, like others in the lowlands, may once have been part of an ancient ocean. Evidence for such an ocean is tantalizing: low elevation basins, potential shorelines, and sedimentary patterns that suggest wave action. If Mars ever had seas, the northern hemisphere is where they likely gathered, pooling in the vast depression that spans much of the planet's upper half. You float above the border between Acidalia and Chrysae Planitia, where enormous outflow channels once carried torrents of water from the highlands. These channels, including Kasai Valles, Tio Valles, and Aries Valles, are immense. They dwarf Earth's rivers in both length and width, some stretching over 2,000 kilometers. Their formation likely involved sudden, catastrophic flooding, events where underground ice melted rapidly and burst forth, carving canyons and dragging debris across the plains. The scale of these floods is difficult to comprehend. Imagine Niagara Falls, but 1,000 times more powerful, pouring not over hours or days, but over weeks. The resulting channels are vast scars, their floors littered with boulders, islands, and streamlined knobs, all shaped by the force of ancient water. At the mouths of these channels lie giant alluvial fans, deposits of sediment left behind as the floodwaters slowed. These fan-shaped structures are key indicators of past liquid movement, and they often resemble deltas seen on Earth. Here, water met stillness, and the land bore witness. You pause now over a small feature called the Pathfinder landing site. It sits quietly in Ares Vallis, marked only by a tiny cluster of mechanical remnants. The lander, the rover, and the tracks they made long ago. This is where humanity first saw the surface of Mars in colour, in motion. The view is unassuming, but the historical weight is enormous. Here, for the first time, Mars became not just a dot in the sky, but a place. From this low vantage, the sky appears wider, the horizon stretches out forever, the sun hangs lower than on Earth, its light softer and more diffuse. It casts long shadows even at midday. Dust particles in the air scatter blue light, so sunsets on Mars are tinged with greyish blue instead of red, a reversal of Earth's familiar palette. You stay a while longer, letting the sky dim. Dust devils dance in the distance, slender columns of rotating air, lifting fine soil into the air. These twisters are common on Mars, and though they look delicate, they can stretch for kilometers and move at surprising speed. In some areas, they leave visible trails, stripping dust away and revealing darker material beneath. The planet records even its smallest weather events. As night falls again, the temperature drops sharply. Without an atmosphere to hold in heat, Mars cools rapidly. Any remaining warmth radiates into space, leaving the surface frigid and dry. Frost forms on shaded rocks and inside deep craters. At times, carbon dioxide in the air condenses into a thin layer of snow, not water ice, but dry ice, glistening faintly under the stars. And there are many stars. The Martian sky is clean and crisp, untroubled by clouds or light pollution. Constellations are familiar but slightly shifted. From this world, Earth is just another wandering light, a bright bluish speck that rises and sets like any other celestial body. You watch as Phobos again arcs overhead. In the silence of Martian twilight, you can almost sense its orbital urgency, how it races the sun, rising in the west and setting in the east just hours later. This is a world frozen in motion, shaped by violence, preserved by cold, eroded by time. And though lifeless on the surface, Mars is anything but still. It pulses quietly, waiting to be understood. It's in these quiet moments that the soul of the red planet reveals itself, not in fire or flood, but in dust and shadow, in valleys carved by ancient hands, in rocks that remember warmth, and in skies that still look toward home. Leaving the northern plains behind, you begin your path southward once more, heading toward the region known as the Martian poles. These areas mark the boundary between seasons, climate, and the fragile balance of Martian water. The northern polar cap is a vast dome of water ice mixed with dust. It grows and recedes with the changing seasons, expanding in winter and shrinking in summer. Beneath its surface lies layers of ice and sediment stacked like pages in a book, each one chronicling thousands of years of climate change. Scientists have studied these layers to understand how Mars's atmosphere has fluctuated and how water cycles shifted over time. The polar cap itself spans hundreds of kilometers, a glistening beacon in the pale sunlight. During the Martian winter, temperatures plunge so low that carbon dioxide from the atmosphere freezes and falls as dry ice, forming a seasonal layer on top of the permanent water ice. When spring returns, the dry ice sublimates back into gas, often causing jets of carbon dioxide gas to burst through the surface, lifting dust and creating dark spots and streaks. These seasonal changes shape the landscape in subtle yet powerful ways. The polar dunes shift and reform, while dust storms carry particles that settle and reshape the ice. The cycle continues quietly, relentlessly, a natural rhythm far removed from the bustling life on Earth. You turn your gaze to the South Pole, where another ice cap reigns. Smaller but more heavily layered, the southern cap is composed mostly of water ice, covered by a thicker seasonal dry ice layer than its northern counterpart. Its layered deposits are deeper, suggesting a more complex history of deposition and climate variations. The southern polar terrain is rugged and fractured, its surface pocked by craters and patterned by polygonal cracks formed by the repeated freezing and thawing of ground ice. These features mirror similar patterns in Earth's permafrost regions, revealing Mars's ongoing interaction between ice and rock. Near the poles, the atmosphere grows even thinner, colder and drier. The sky's pale glow is punctuated by the sharp light of distant stars, unfiltered by clouds. Auroras, though faint compared to Earth's, have been observed, hinting at interactions between the solar wind and Mars's patchy magnetic field. As you explore the edges of the polar caps, you notice deposits of perch laurets in the soil, chemical compounds that lower the freezing point of water. This suggests that liquid brines might exist transiently beneath the surface, where temperatures are slightly warmer and salts prevent freezing. These brines may flow underground in isolated pockets, offering one of the few places where liquid water persists today. This discovery is tantalizing because liquid water is essential for life as we know it. If microbial life survives on Mars, these subsurface salty waters could be its refuge. Protected from radiation and extreme cold, you imagine the ice layers as a planetary memory, locked away for millennia. Within them lie records of dust from distant impacts, tiny bubbles of ancient atmosphere, and chemical clues about Mars's evolving environment. Future explorers may drill deep into these layers, unlocking secrets as profound as those hidden in Earth's ice cores. Stepping back from the polar ice, you look across the vast expanse of Planum Australe, the southern polar plateau. Its surface is streaked with dark sand dunes, shaped by shifting winds that play across the ice fields. Though lifeless to the eye, this region hums with geological activity on a slow, frozen scale. The contrast between the poles and the equator could not be greater. Near the equator, ancient riverbeds and volcanic plains tell stories of water and fire. Near the poles, ice and dust govern the landscape, preserving a frozen history. Mars's water, once plentiful on the surface, now hides beneath layers of rock and ice. What remains is a planet caught between worlds, a desert of stone and frost, shaped by the ebb and flow of water that vanished long ago. As night deepens, you look skyward once more. The two moons, Phobos and Deimos, continue their silent dance. Phobos rises quickly, crossing the sky in a matter of hours, while Deimos drifts slowly, lingering at the horizon. Their irregular shapes and cratered surfaces remind you that Mars's story is one of constant change and survival. The stars shine bright and steady. Far off, the glow of the Milky Way arcs across the sky, its countless suns shining as silent witnesses to the red planet's quiet vigil. And as you stand in the stillness of this alien night, you reflect on the fragile beauty of Mars, a world shaped by fire and ice, wind and dust, light and shadow. A world that sleeps beneath the midnight sky, waiting patiently for the day it may again awaken. Tonight, as our voyage across Mars comes to an end, we reflect once again on this remarkable world under its midnight sky. Mars, the red planet, is a place of contrasts and quiet wonders. We began our journey with the soaring heights of Olympus Mons, the vast canyons of Valles Marineris, and the dusty plains shaped by ancient rivers and volcanoes. We've travelled through frozen glaciers hidden beneath the surface, wandered ancient river valleys etched by water long gone, and stood beneath polar ice caps that guard secrets frozen in time. This world, though seemingly silent and still, holds stories written in stone, dust, and ice. Stories of change, resilience, and possibility. Mars reminds us how planets evolve over billions of years, how water shapes worlds, and how even in silence, a planet can pulse with memory.
As you rest now, imagine the cool Martian night, the gentle shifting of dust carried by faint winds, the distant dance of Phobos and Deimos crossing a sky so clear and vast it seems infinite.
Sleep is a time of rest and renewal here on Earth, and perhaps in the quiet of Mars's nights, there is a parallel rest, a pause before future chapters of exploration, discovery, and maybe even life. Thank you for joining me on this peaceful journey through the Red Planet. Wherever you are in the world, I invite you to comment your location and time below. Let's connect across distance under the same stars that watch over Mars. May your sleep be calm and your dreams vast, like the endless plains and canyons of Mars. Until next time, this is Sleep Space, wishing you gentle rest beneath the cosmos.